Hello everyone, and welcome to our video on the elasticity of demand. So what this does, let's read it. It says, to measure the sensitivity of demand to a small increase in price, economists calculate the elasticity of demand. So it's just letting us know, like if we had something for $10 that they're selling, if they raised it to be like $10.50 or $11, will that give them more revenue at the end of the day, or will that hurt them? Okay, because a higher price means probably less are going to be bought. Okay, lower price, more would be bought. So all of that summed up in this elasticity of demand equation. So it's just letting us know if it will be worth it for the seller. All right, and then from the elasticity of demand, when we calculate it, we want to know whether or not it's less than 1, greater than 1, or equal to 1. So when the elasticity is less than 1, we say the demand is inelastic, which means a small rise in price will result in an increase in total revenue. Whereas if we calculate it and it's greater than 1, we say the demand is elastic, which means a small rise in price will result in a decrease in total revenue. And then if it does equal 1 right on, then that means the total revenue is maximized, and that's called unit elasticity. Okay, so all that vocabulary comes with it. So let's see how it works. So in this problem, it says Steph's Cupcakes determines that the demand function for its vanilla cupcakes is Q equals D of X equals 125 minus 20X, where Q is the quantity of the vanilla cupcake sold when the price is X dollars per vanilla cupcake. Find the elasticity. Okay, so that's this equation. So we just want to make sure we've got this nearby when we're doing elasticity problems. So I'm going to just write it all the way out right here. So we've got E of X is negative X times the derivative of demand over the demand. One way that I think of it is that it's kind of like the logarithm derivative, where we have just instantly the demand functions down below and the derivative of it's up top. But then we do have to remember to do a negative x in the front. Okay, so again, just have it nearby, or maybe break it down the way I thought of it there. Okay, and they told us what d of x is. Okay, so we have d of x. I'm just writing that also right here. So we have 125 minus 20x. We need its derivative, so might as well calculate that too. Let's do it in blue. So the derivative of our demand function would be just negative 20. So that's what's going to go right there. And so then we'll just substitute that in. So our elasticity, E of x, is negative x, and then in the blue still, negative 20. And then d of x is the 125 minus 20x. So we just sub that in directly into the denominator. And then we just do one thing of cleanup. Notice the top would multiply to give us positive 20x. And then the denominator is still 125 minus 20x. Okay, so that's the elasticity. So it's just the function based on the formula. All right, now step 2 is saying at what price is elasticity of demand equal to 1? So that, and they might write this as when is it having units elasticity? Or they might say when is revenue maximized? So those all are equivalent ways to state the same thing, which is really just to have the whole function. Let's go ahead and write the same function just to have it again. So E of x is 20x over 125 minus 20x. They're saying we should have this just equal 1 on the left side there, and then the right side stays the same, like so. And if it helps, we can put a 1 down there, because what we are doing now, we have a fraction equal to a fraction, so that means we can cross multiply. Well, as we cross multiply from the bottom right to the top left, 1 times 125 minus 20x is 125 minus 20x. And then as the 1 down in the bottom left multiplies the top right, we have 20x. And then so now let's solve this equation. Solve. So it looks like I should add the 1 on the left, I should add this 20x over. So we have 125 is equal to 40x, and then we could divide both sides by 40. When we divide both sides by 40 there, okay, so a little out of room, let's start to put it up here. So we would have 125 divided by 40. And then, well, we would probably want to simplify this. Notice that both of those are divisible by 5. And we could also use a calculator, which we'll probably do anyway to get a decimal. Okay, but this would be 25 over 8 is x. And then what we could do, we could plug that into a calculator. Okay, so if we did that, we would get 3.125, but it's asking for a price, so we would probably round it to the nearest cent, so $3.13. Okay, so because they said X is in dollars. Okay, so that's it. So it looks like that's what the price should be for these cupcakes to maximize profit. Now that maybe is a strange price in real life. If you go to a cupcake shop, you're probably not paying that. They might just make it like $3.10 to make it easier, but still, this is the idea for finding the maximum revenue. Now, again, in real life, probably this demand equation is hard to figure out and complicated, but still, we can take these practices to help us or help businesses. All right, so let's see the next two parts. So what's either good or bad about these, you just continue using the same stuff over again. Okay, so number 3, it says, at what prices is demand elastic? Okay, so that's over here. So this part, that second bullet, so that's when E of X is greater than 1. Okay, so what we'll do, with this problem, since we solved for number 2, we're going to just use this again. Okay, so for anything, making sure it's greater than 1. So this is the X value. So let's write it right here. X equals 3.13 gives us E of X equaling 1. So that means we should just make this X bigger, and that should make our price elastic. Okay, so anything bigger than 3.13. Okay, so X greater than $3.13 are the prices that would make the demand elastic. So we're just taking our information from the previous problem. Okay, so real nice there. So finding that first can save us a lot of time. So we don't actually have to set up an inequality. We're just using our information from that first, or number 2. And then similar with inelastic. Inelastic is when E of X is less than 1. Well, again, we can take this same information. We know when X is 3.13, E of X equals exactly 1. So that means we should make the X smaller to make the E of X less than 1. Okay, so X smaller than 313 makes the price inelastic. That's all it takes. Okay, so we've got our 2 answers there. We can move on. All right, so number 5, at what price is the revenue a maximum? So we already talked about this on number 2. So we said, oh, the way that they worded this could have been worded these 2 other ways. They could have said, when is X giving us unit elasticity, or when is revenue maximized? Well, it's this same one. So number 2 is still the same answer for number 5. X is $3.13 still. There we go. All right, nice. Okay, so again, this is kind of key to this whole problem. All right, number 6. It says, at a price of $4 per vanilla cupcake, will a small increase in price cause total revenue to increase or decrease? Okay, so small increase in price. So they're asking about $4. Well, again, we already have this. There we go. Let's use this again. So $4 is greater than 313. And that's when we had demand being elastic. Okay, so that is this case right here. all of that. So again, we're just kind of carrying over a lot of the same information. But now that we have that, well, we just have to remember, what does elastic mean? Okay, so this is elastic. So they might ask that too. Well, if it's elastic, we had it up there in the bullet. A small increase in price will make a decrease. So it's right here. Small rise in price will result in a decrease in total revenue. Okay, so that's too much because 313 is already the maximum revenue. So if we change it, it's not going to go well for us. Okay, so we've got, let's finalize it. Small increase in price causes let's say causes total revenue to decrease. Okay, so there's the two connections. So elastic and this, again, mean the same, but just worded in a different way. Okay, so that's it. So that's how we deal with the elasticity of demand. So we use the equation to find this function. And then from there, we do just lots of little things, kind of repeating itself. All right, so we'll do another example, but in a different video. So thanks for watching. If you have any questions, please let me know.